In this video, we will solve a numerical problem on Keynesian National Income model. The question is, consider the following Keynesian National Income model. Y is equal to C plus I naught plus G naught. Y denotes the output, C is the consumption, I denotes the autonomous investment, and G denotes the autonomous government spending. Consumption is a function of that is A plus B. A is the autonomous consumption when income is equal to 0. B denotes the marginal propensity to save uh, times Y minus B T naught, where T naught is the lump sum tax here. Where A and B are parameters with the following range. A is greater than 0, that means this A is greater than 0, and this B marginal propensity to consume lies between 0 and 1. We are being told what are exogenously determined variables in this model. First question is this. Second is show that this model can be expressed in the following matrix form. Okay. Third is use matrix algebra to find the solution for equilibrium income and equilibrium consumption. And D part is suppose government spending increases by some amount, let us say del G naught to become G naught plus del G naught. Show that change in income and consumption as response to this increase in government spending. Okay, let us go one by one. Okay, first we are being told what are exogenously determined variables in this model. Okay, so since Y is a function of consumption, investment, and government spending, by exogenously or by exogenous variables, what we mean, exogenous exogenous variables are those variables whose value is determined by the forces outside the model. Okay, any change is regarded as autonomous. In the given model, we can see this I naught denotes the autonomous spending, autonomous investment, and G naught is our autonomous government spending, and T naught is the lump sum tax. These three variables are called the exogenous variables because their value is determined outside the model. That means exogenous variables in this case are, and let me write it here, we have I naught, which is the autonomous spending, which is not determined within the model. We have the government X G naught, which is autonomous government spending. This does not depend upon the level of income, and here we can see investment does not depend on the level of income, and T naught, that means the lump sum tax, that also does not depend upon the level of income or consumption here, on income here. These three variables are called the exogenous variables. And one thing is here, our Y, that is income. Income depends upon these values. These are called the endogenous variables. Y is the endogenous variable, and C is also the endogenous variable. Those variables, okay, whose value is determined within the model are called the endogenous variables. Income and consumption are the endogenous variables, and those variables whose value is determined by the forces outside the model, these are called the exogenous variables. So this is the first thing. Second thing, second part of this question is show that this model can be expressed in the following matrix form. Okay, so let us rewrite this equation. As we have told, C, Y and C are the endogenous variables. Let us put all the endogenous variables to one side. So I can write this equation in this form, that is Y transposing this C here minus C is equal to I naught plus G naught. Okay, what I have done, I have rewritten this equation in such a way that all endogenous variables are on LHS and exogenous variables are on RHS. Same thing I will do for this equation. Here, as I have told you, if I rewrite this equation here for the sake of simplicity, okay, so we have C is equal to A plus multiplying this B, so this becomes BY minus, here it is only Y minus T naught, Okay, so b times y is by minus b t naught. Okay, so if I transpose the endogenous variable is here by, so I can write this equation in this form, that is minus by plus c is equal to a minus b t naught. Okay, so when I solve this, I will get this thing, that is minus b minus b, sorry, minus b, then we have this plus c, minus b plus c is equal to a minus b t naught. Okay, I have rewritten these two equations in such a way that endogenous variables are on LHS. Here we have by, sorry for this mistake, and exogenous variables are on right side. Okay, now let us define something here. Let me define a matrix here. A is equal to, A is called the coefficient matrix. The coefficients of y's and c's denotes our coefficient matrix. The coefficient of y in this first equation is 1, so I will write here 1. Okay, the coefficient of y in second equation is minus b. Let me write it here, minus b. Now the coefficients of c's are, the coefficient of c here is minus 1. Let me write here minus 1. And the coefficient of c in the second equation is plus 1, and let me write it here, this. So A is called the coefficient matrix, the coefficients of endogenous variables here, okay, in the matrix form. Then we have x, okay. X is our, what we call the solution vector. X denotes our y and c vector of solutions, or solution vector. And we have another, what we call b. Okay, let me write it in this fashion. B is the vector of constant terms. And what is the vector of constant terms? These are our vector of constant terms. That is I naught plus G naught. And we have A minus BT naught. Okay. When we write it in algebraic form, how do we have to write it? We have to write it in this fashion. That means A x is equal to B. Okay, when I rewrite these equations in the matrix form, so this is the procedure. So A is our 1 minus B minus 1 1 times x, that is solution vector. Solution vector is y and c is equal to b. B is our vector of constant terms, which is equal to I naught plus G naught A minus B T naught. Okay, so this is the solution to this second question. Okay, that I have expressed these system of equations in matrix form. Now the third part tells us to use matrix algebra to find the solution of y and c. To find the value of y and c, what will we do? So this is our c part now. Okay, c part. Okay, what will we do? Okay, now first thing is we need to find out the determinant of the coefficient matrix. This is our coefficient matrix. This A is equal to this. If I take the determinant, let us say write determinant in this form. Okay, how do we find the determinant for here? We multiply these two numbers. 1 into 1 is 1. Then we subtract and multiply these two numbers. That is minus 1 into minus b. So minus into minus is plus. So we will get b here. Okay, simple thing. To find the determinant, we multiply these two elements, then we write minus and multiply these two element. So minus into minus is plus, so we are left with 1 minus b here. Okay, simple thing. Now to find the value of y, okay, to find the value of this y, what we do, we replace first column of this coefficient matrix with the vector of constant terms and form new matrix. Okay, I will not write it here. I repeat, to find the value of y, we replace first column of coefficient matrix with the vector of constant terms and form a new matrix A0. Let us say A1. Okay, let me write it here. A1 is a matrix which is formed by replacing the first column with vector of constant terms, So in place of 1 minus b, I will write this I naught plus g naught, and we have a minus b t naught. Okay, then we have minus 1 and 1, minus 1 and 1. Okay, simple thing. What I have done to find the value of y, I replace first column of the coefficient matrix with the vector of constant terms and form new matrix. Then what I have to do, I have to take the determinant of this matrix. Okay, or let me write it here. Now I take the determinant of a1. Let me see if I have space here, and okay, let me write it here. So the determinant of a1 is equal to, simple thing, how do we take determinant? First we multiply these two elements. Okay, and let me show it here. So if this is our matrix, we multiply these two, so we have I naught plus g naught. To this we multiply 1, so it will remain same. Then we write minus, okay, and multiply these two elements. So we have here minus 1 times a minus b t naught. Okay, simple. If we have 1 2 3 4, if this is our matrix A, then its determinant is simply, we multiply these two, that means 1 into 4, then subtract and multiply these two, 3 into 6. Okay, same thing I am applying here. Okay, when we solve this, it will become I naught plus g naught, minus into minus is plus, so we will get plus a, then we have minus into minus is plus, plus into minus is minus, so minus b t naught. Okay, and let me write it here. I don't have the space here. Okay, let us find the value of a here. So our a1, the determinant of this came out to be, when I multiply these two, I got I naught plus g naught plus a minus b t naught. Okay, now to find the value of y, what will we do? Simply we write y, the value of y will be equal to the determinant of new matrix a1 upon the determinant of coefficient matrix. Determinant is here this I naught plus g naught plus a minus bt naught. To this we divide by the determinant of a. We have calculated the determinant of a, that came out to be 1 minus b. 1 minus b. This is the solution of income, that means equilibrium level of income. Now we are being told to find the equilibrium level of consumption. Okay, now equilibrium level of consumption, simple thing, what we do now to find the value of c. Okay, here let me write it here. Now to find the value of c, we replace the second column of the coefficient matrix with the vector of constant terms and form a new matrix a2. Okay, so a2 will be equal to we form new matrix in such a way that we replace the second column of the coefficient matrix with the vector of constant terms. That means uh, first column will remain same, that is 1 minus b, and we replace this minus 1 and 1 with this vector of constant terms this time. So we have I naught plus g naught, then we have a minus b t naught. Okay, now we take the determinant of this a2. So determinant of a2 will be simple thing, multiplying these two elements first. So 1 into this stuff, it will become a minus b t naught. Then we have minus from the formula and we multiply these two here. That means we have minus b times I naught plus g naught. Then it becomes a minus b t naught minus minus into minus is plus, we will get b I naught, minus into minus is plus, so b times it will become plus b g naught. So this is our determinant of a2. Now to find the value of consumption. So to find the value of c, what will we do? We write the determinant of a2 upon the determinant of the coefficient matrix. So determinant of a2 is this stuff. Okay, and let me write it here. It is a minus b t naught plus b I naught plus b g naught. To this we divide by the determinant of a. The determinant of a is 1 minus b, and let me write it here, 1 minus b. Okay, that means this is the solution. The equilibrium value of income will be this, equilibrium level of consumption will be this stuff. Okay, the third part tells us, suppose government spending increases by some amount del g naught to become g plus del g naught. Show that the changes in income and consumption as a response to this increase in spending. Okay, we need to find out. Okay, we need to find out how will our income change and consumption change when government spending changes by del g naught. Okay, for that, what will we do? And let me write it for the income. If I write our equilibrium level of income is this, if I write it again, so d part is, let us rewrite this equilibrium level of income, that is y is equal to, so let us write it in this fashion, I naught upon 1 minus b. Okay, I can expand this, plus g naught upon 1 minus b plus a minus b t naught upon 1 minus b. Simple thing. I have expanded this. Now what we are being told, how our income changes when there is change to the government spending by del g naught. That means we need to find out the change in income with respect to change in government spending. Okay, so we need to find out how our income changes when there is change in the government spending, and this is done simply by taking the derivative of this equation with respect to g naught. Okay, so rather partial derivative here, since no g naught is in the first term, its derivative is 0. Derivative of g naught is 1 here, so we will get here 1 upon 1 minus b. In the third term, no g naught is involved, so its derivative is 0. So that means change in income divided by change in government expenditure will be equal to 1 upon 1 minus b is our MPC. Okay, so we can write it in this fashion, 1 minus, this is our marginal propensity to consume. That means our change in income will be equal to 1 upon 1 minus MPC, okay, times change in government spending. Okay, this we got this result. Okay, this pattern I have explained it here. I have explained it here. Now we are being told what will happen or how will the consumption behave when the government spending increases by del G naught. Okay, first what we need to do here, let us rewrite the income equilibrium level of income equation. This is our equilibrium level of income equation. So this is y is equal to, if I rewrite this in this fashion, so if I write a minus bt naught this upon 1 minus b, I am expanding this again, plus we have bi naught upon 1 minus b plus bg naught upon 1 minus b. We are being told how our, sorry, this is magenta, this is our consumption. Okay, simple thing, we need to find out how our consumption changes when there is change in government expenditure. That means we need to find out change in consumption with respect to change in government expenditure. That means we need to take the derivative of this function with respect to g naught. No g naught is involved in the first term, its derivative is 0. No g naught is involved in the second term, its derivative is also 0. Then in the third term we have the g naught. The derivative of g naught by power function rule, power like this, is 1. So we are left with only b. So we will get b upon 1 minus. So this is 1 upon b, and it can be written in this fashion, that is b is our marginal propensity to consume upon 1 minus mpc. Let us rewrite it here. That means our change in consumption will be equal to, we have mpc upon 1 minus mpc. Transposing this here, it will get multiplied times change in government expenditure. That means change in consumption will be equal to this term times the change in government expenditure. Okay, I hope I make myself clear in this video. I have solved these type of questions, and you can check the national income model where we have used the Cramer's rule. Okay, to solve these system of equations we have actually used the Cramer's rule. Okay, so I hope I make sense in this video. Okay, thank you.